Can you guys see the screen?
Yes, ma'am.
Yes, so yesterday we did concepts like half the concepts of time, speed, distance, where we covered the basic relationship between time, speed, distance, the three variables, the proportionality between the variables, um, relative speed, average speed, and problems related to trains. So we'll now start with the questions related to the concepts we did yesterday. So they'll be little more fit in your head. Uh, Going with the first question. Seema can cover a distance of 2880 meters in 20 minutes, while Seema can cover 3 kilometers in 900 seconds. Who is faster? So, you would like to try. Just make sure that you get both Rima and Seema speed in the same unit. So, what unit you want to go for? You can think about that. What unit would you like to go for both of them? Only then we can compare their speeds.
Meter per second?
Meter per second is what you can do. So Rima's distance is already in meter. And how will you convert 20 minutes into seconds?
20 into 60.
Yes, ma'am.
Okay, so 6 fours are 24, 6 eights are 48, 2 and 24. So it's basically 2.4 meter per second, right? For Rima. Same, let's try to figure out for Seema. 3000 meters per second. What will that come down to? 3.3 meter per second. So who is more faster?
Seema.
Do we understand this? Very simple question. Just being careful about the units for distance and time. Moving to the next question. Let's try this. A journalist traveled 1080 kilometers by aeroplane, and this formed 3/5 of his trip. If the speed of airplane is 250 meters per second, then how much time will it take to reach the destination? Anybody who would like to take me through the solution? What is the total distance that airplane needs to cover?
So we can take 3/5 of total distance is 1080. So the total distance will be 1080 into 5 by 3.
Ma'am, for this question, do we need to convert it into meters per second? Or can we just...
Because my question is in hours, I would rather keep kilometers in kilometers, and I would convert my speed from meter per second to kilometers per hour.
Okay, ma'am.
But what is the total distance that you're coming down?
1800 kilometers.
1800 kilometers. And my speed is 250 meters per second. How do you convert meters per second to kilometers per hour?
Into 18 by 5.
Into 18 by 5. That is 550s are 18 5s is 90. So this is 900 kilometers per hour. So how many hours will it take? I think now it is just to be done mentally.
2 hours.
2 hours. Okay. Moving forward. Anuj likes to jog in a park. While jogging, he also calculates his speed and the number of steps taken by him. He observes that the steps taken by him per minute are 5 times his speed in kilometer per hour. So number of steps is 5 times his speed in kilometer per hour. What is the distance he covers per step if he jogs at a uniform speed? So here, how can you do that? If he jogs at a uniform speed, which was in kilometers per hour and steps per minute. So let us try to assume his speed. Okay, we are asked what is the distance he covers per step. Let us try to assume his speed and see if we are able to get the answer or is the data insufficient. Fine?
Yes, ma'am.
Okay, so what I am doing is, let's say I am assuming his speed to be 10 kilometers per hour, which means he runs at a speed of 10 kilometers every hour, which means every minute. And I am said that the steps taken by him per minute are 5 times his speed in kilometers per hour. So I know that steps taken by him would be 10 into 5, 50 steps per minute. Do we understand this?
Yes, ma'am.
Okay. Now, if I am running 10 kilometers in 1 hour, which means I am running 1000 kilometers in 60 minutes. Sorry, 1000 meters, not 1000, 10,000. 10,000 meters in 60 minutes. In 1 minute, I will be running how many meters is what I will get? Did you all first understand this? 10 kilometers is 10,000 meters in 1 hour, which is 60 minutes. So 60 minutes, 10,000 meters, 1 minute is how many meters? Right? Now,
Yes, ma'am.
these many meters are covered in 50 steps. Do you understand this? Because in 1 minute, he takes 50 steps. So these many meters are covered in 50 steps. So if 50 steps are taken to cover these many meters, in 1 step, how many meters would be covered? Did you get my comparison?
Ma'am, but the 10,000 meters is for 60 minutes and steps are 50 per minute. So how do we correlate?
Okay. Steps are 50 per minute. That is why I found the distance covered in 1 minute. 10,000 meter is for 60 minutes. So for 1 minute, the distance covered would be 10,000 divided by 60.
Yes.
And I used that here. 50 steps cover this much distance. So 1 step will cover 10 by 3 meters.
Okay, got it.
Okay, I might also want to check that whether if I change my speed, is my answer remaining same or is it changing? If it changes, it means that my data is insufficient. And if it remains same, it means that with any speed, my answer will be same. Correct?
Yes, ma'am.
Okay, so what I'll do is I'll just change my pen color to compare. Let's say instead of 10, I'm taking my speed as 20. Okay, which means the steps will be 100 steps per minute. Okay, according to the speed, it means I'm traveling 20,000 meters in 60 minutes. So 20,000 meters upon 60 per minute. Do we understand this? Now, if 100 steps are covered in this much time, so 1 step would be covered in how much? 100 steps covers this much distance. So 1 step will be covering how much distance? This I'll have to do. What do you think? Your answer will be same or different?
It's the same.
It's same, which means 10 by 3 is the correct answer, irrespective of what speed you assume. All right, moving ahead. Mr. Sahu walks to the market and comes back in an auto. So he's walking one way and he's coming back. He comes back in an auto. Okay. It takes 120 minutes to make the round trip. Okay. If he takes auto both the ways, it takes 40 minutes for a round trip. On a Sunday, he decides to walk both the ways. So how long would it take him? This is a very logical question. If somebody would want to try. There is no calculation required. Anybody who wants to try?
Ma'am, does it take 60 minutes for him to...
60?
No,
For him
sorry,
to
ma'am,
walk
not 60.
80 minutes.
how much?
80 minutes.
To walk both ways?
To walk one way.
Yes.
That's what I'm asking. What should be your final answer? So if he takes an auto both ways, it takes 40 minutes. So auto single way takes how many minutes?
20.
20 minutes. So auto single way takes 20 minutes, which means walk single way takes how many minutes?
100.
100. So walk double way will take how many minutes?
200.
Are we clear? It's a logical, common sense question, nothing else. Moving ahead. Okay, this is an interesting question. I would like all of you to pay attention. By walking at 3/5 of his speed, a man reaches office 20 minutes later than usual. What is his usual time? Now, this is the type of the question where we will be using the offset method that we used in percentage. If you remember, we said that whenever there are two variables which are inversely proportional to each other, the increase decrease between the two variables can offset each other. Do we remember that?
Yes, ma'am.
So here also we know that speed into time is equal to distance, which means speed and time are inversely proportional, which means increase in speed will be offsetted by decrease in time and vice versa. Now, let's say my original speed was s and t and the distance covered was d. Now the man is working at 3/5 of his usual speed. Has my distance changed? My distance has not changed.
No.
So to balance off my 3/5 speed, what should happen to my time?
5/3.
Correct. 5/3 of
original.
t. Did we understand this step? So clearly time has increased. From t to 5/3 of t, time has increased. What is the increase in time? You can always calculate the increase in time by taking the difference between both of them. So the increase in time is 2/3 t. Agreed?
Yes.
And what is said, because of this reduction in speed, he reaches office 20 minutes late than usual, which means he takes 20 minutes more than the original time. So can I
Yes.
say the increase in time is nothing but 20 minutes? So my original time, which was t, is nothing but 30 minutes. What is his
Yes.
usual time? 30 minutes. What is his increased time? 50 minutes. Do we get that? Moving ahead. The speed of scooter, car, and train is in the ratio 1:3:9. If all of them cover equal distance, what will be the ratio of time taken upon speed for each one of them? So speed ratio is 1:3:9. So what should be, and they are covering equal distance. So first thing is, what would be the ratio of time taken? If they are covering equal distance, can I say speed is inversely proportional to time?
Yes.
So what should be the ratio of time? First tell me that.
1/1, 1/3, and 1/9.
Correct. So if I have to simplify these,
Nine is to 3:1.
very good. 9:3:1. Now I am said the ratio of time taken upon speed for each of the vehicle. So for the first vehicle, time taken upon speed is 9. For the second vehicle, time taken upon speed is 1. And
One.
for the third vehicle, time taken upon speed is 1/9.
Yes.
So if I simplify this, what should be my answer?
81:9:1.
Correct. Did we understand this?
Yes, ma'am.
Clear, everyone? Okay. Moving ahead. All right. Let's look at this. Two trains, they start at the same time from Hyderabad and Delhi. In such questions, I would always advise you to draw a diagram. Okay? They proceed towards each other at 80 and 95 kilometers respectively. So train traveling from here has a speed of 80 kilometers per hour. Train traveling from here has a speed of 95 kilometers per hour. When they meet, it is found that one has traveled 180 kilometers more than the other. We don't know the total distance between them. We are supposed to find that. But clearly, because this second train is faster, they will meet nearer to Hyderabad. Okay. And it is said that when they meet, the distance traveled by one train, let's say this train, is 180 kilometers more than the distance traveled by this train. Do we understand this? So
Yes,
now,
ma'am.
anybody who would like to tell me how we can proceed on this? There are multiple ways to do it, but again, I would leave upon you. If anything that comes to your mind, it's a very simple, practical question. Don't go into complex complex concepts. It's a very simple question. Just think about it. Okay, there are two methods for this. Let me show you both the methods. I was expecting at least one would click. Okay, for both the trains, they are leaving at the same time, right?
Yes, ma'am.
And they are meeting at the same time. So can I say for both the trains, their travel time is same? So if travel time is same, can I say speed is directly proportional to distance?
Yes.
Which means speed 1 upon distance 1 is equal to speed 2 upon distance 2, or the ratio of speed and distance is same basically, right? Now my speed 1 is 80, my distance 1 is d, my speed 2 is 95, and my distance 2 is d plus 180. I might want to solve this, get the value of d, and my answer is actually 2d plus 180. This is one way, but I would not do this also. But did we understand this way? That is more important.
Yes, ma'am.
Yes.
Okay, now let's see the other way, which is more practical. If I talk about first train covers 80 kilometers every hour. And the second train covers 95 kilometers every hour. So how many kilometers per hour does the second train cover more?
15.
So if I'm covering 15 kilometers more in 1 hour, if I want that train to cover 180 kilometers more, how many hours are required?
180 by 15, so 12.
12. So which means both the trains are traveling for 12 hours. Do you agree with this? Both the trains are traveling for 12 hours each. Only then, see, both the trains are traveling for the same time. Fine. So in 1 hour, if second train is covering 15 more, to cover 180 more, it has to travel 12 hours, and first train will also travel for 12 hours. Agreed with that?
Yes.
So in 12 hours, first train will cover how much distance? 80 into 12. What will that
960
be?
kilometers.
960 kilometers per hour. And instead of doing 95 into 12, I know that the distance covered by second train is 180 more. So distance covered by second train has to be 960 plus 180. Agreed? Which is what? 1140?
Yes.
So now 1140 plus 960 is the total distance between the two stations, because that is how the entire distance between the stations is covered. And my answer would be 2100 kilometers.
Got
Clear?
it.
Okay. All right. Then moving forward. A man and woman 126 miles apart from each other start traveling towards each other at the same time. So let's say there is a man here, there is a woman here, and the distance between them is 126 miles. If the man covers 8 miles per hour and woman covers 6 miles per hour, how far will the woman have traveled when they meet? This time, definitely not doing it. I want you to do it.
54 miles.
Very good. 54 miles is correct. How?
We can take the ratio of their speeds and divide the distance in the same ratio.
Perfect. Because they are starting at the same time and meeting at the same time, which means time is constant. So speed is directly proportional to distance. Speed, the ratio is 4:3. So distance also has to be covered in the ratio 4:3. So I can divide 126 in that ratio. Is everybody clear with this? Or you can also use the concept of relative speed. I know the distance between them is 126 miles and the relative speed between them would be 14 miles per hour, which means they will take 9 hours to meet. So in 9 hours, woman will cover 9 6 are 54 miles. Whichever way is fine. Any question,
ma'am.
any doubt here?
No, ma'am.
Okay, let's look at this. A man travels 3/5 of the distance AB at a speed 3A and a remaining at a speed 2B. If he goes from B to A and returns at a speed of 5C in the same time, which of the following is true? All right, so basically they are saying that if I talk about A and B, because they have used 3/5, I'm going to divide the distance between A and B in 5 equal parts, where each part is x. Okay, now they are covering 3/5 of the distance at a speed of 3A and remaining at a speed of 2B. So first of all, let us calculate the time taken to do this. Now time taken is the time taken for the first part plus the time taken for the second part. Now how do I calculate time taken? Time taken is distance upon speed. So what will be the time taken for the first part? 3x
3x upon 3a,
plus
2x upon 2.
correct. Now this is the time taken for the first part of the question. Now they say if they go from B to A and return at a speed of 5c in the same time, which means if, so again, I'm going and returning, right? So my time taken will be to and fro journey. So my first part of the journey will be 5x, right? And my second part of the journey will again be 5x. So my total distance is 10x at a speed of 5c. Do you agree with this?
Yes, ma'am.
Okay, and this time taken in both the cases is equal. Now let us try to simplify what we are getting. So this is 10x upon 5c, where this gets cancelled. Clearly, x is common in left-hand side and right-hand side. So you are left with 1 by a plus 1 by b is equal to 2 by.
2 by c.
Did we understand? It's a see. I think when I look at this question in the first go, I might be a little taken aback. But when you start solving, it's not that difficult. Moving ahead, if a boy walks from his house to his school, so again I'm going to draw over here house and school. at the rate of 4 kilometers per hour, he reaches school 10 minutes early than the scheduled time. Okay. And if he walks at a rate of 3 kilometers per hour, he reaches 10 minutes late than the scheduled time. Okay. Find the distance between the house and the school. Okay. Again, in this case, you can see that there are two different cases of speed and time for the same distance. I know speed into time is equal to distance. Fine. In the first case, if speed is 4, I reach 10 minutes early than my usual time. Let us say my usual time is t minutes, which means this is the correct time. So my usual time is t minutes. So I'm reaching t minus 10. And if I am walking at a speed of 3, I'm reaching 10 minutes late. So t plus 10 minutes. Fine. Now in both the cases, the distance covered is same. Agreed? In both the cases, the distance covered is same. So can I compare both the cases directly? 4 into t minus 10 will give you the distance between home and school. But because 4 is in kilometers per hour and t minus 10 is in minutes, I'll convert it into hours. Also, 3 into t plus 10 will give you the distance between the home and the school. But again, just to maintain the uniformity between units, I'll convert it into hours, but this will not matter at all. So now 4t minus 40 is equal to 3t plus 30. So what am I getting?
T is 70.
T is 70. So the actual or the original time was 70 minutes, right? Now I am asked what is the distance between the school and his house. So distance can be found out by any one of these combinations. So 4 into 70 minus 10 is 60. But again, 4 is in kilometers per hour and 60 is in minutes. So to convert it into hours, I will have to divide it by 60. And thus the distance between home and school is 4 kilometers. Even if you would have taken the second case, your answer would still be 4 kilometers. Right? So distance is same. You just have to compare the cases. Again, see, every question, it is just speed is distance upon time. Just try to put the known parts of the question and you will find the unknown easily. And time, speed, distance is one such chapter which has like huge variations of questions possible. So with every new type, you should not get confused. Just go step by step. All right, let's look at this. Anuva takes 20 minutes less than usual time to reach her office if her speed increases by 5 kilometers per hour. Again, I'm seeing this type over here. My first case is if my speed, let's say my original speed was S. If my speed becomes S plus 5, Anuva takes 20 minutes less. So my time becomes T minus 20 and takes 30 minutes more if the speed decreases by 5. So what is her usual speed or what is S is what is asked. Can you solve and tell me the answer? Okay. I don't think this equation comparison is directly giving me any answer here. No problem. We'll try some other way. If the speed increases by 5 and if the speed decreases by 5, what is her usual speed? So in this case, if I see the reduction in speed overall between two cases, so can I say that along with these two cases, the third case, this also holds true? So in the first case, I increased my speed. In the second case, I decreased my speed. But if I don't change my speed at all, my speed into time, the original speed and original time, will also give me the original distance.
Yes.
Which means I can have one more comparison of distance over here, which is just ST. So one case is ST, another case is multiplication of S plus 5 into T minus 20, and third case is multiplication of S minus 5 into T plus 30. So comparing these two cases, I found this relation between S and T, which is correct. Okay. Now, if I compare this case to any of the case, let's say if I compare these two cases, my ST will get cancelled. So what will I be left with is 20S is equal to 5T minus 100. If I cancel by 5, so 4S is equal to T minus 20. Do we understand what I just did? So now I have two equations and two variables. Can I linearly solve these two equations to find the value of S? Because that is what is asked, usual speed. If I compare T on both the sides, I know that 4S plus 20 is equal to 5S minus 5. So your S is equal to 20. So here, instead of taking two cases, I took three cases, and all the three cases are valid. So you can compare any two out of the three cases, you get two equations, you solve those two equations, you get the answer. Okay. All right, then moving ahead. At 12:30, the engine of a train was exactly midway of a tunnel. Let's say this is a tunnel, and engine of a train was exactly midway at 12:30 p.m., which is thrice as long as the train. So if this is the engine is 3 times long as the train. Okay. It completely emerged from the tunnel after 25 seconds. How much time will the train take to completely cross a tunnel, which is 4 times as long as the previous tunnel? So basically, if I have to talk about, see, in case of engine and train, speed is not going to matter. Speed is going to be same. What will have to matter is the distance and the time. Fine. Now for engine to cross half the tunnel, it takes 25 seconds. Right? Let's draw an equation for this. So let's say speed of the train or speed of the engine is going to be same. Speed of engine is equal to distance. What will be the distance covered? Distance covered will be half of tunnel plus the length of engine. Because from here, if the engine has to move out, it has to cover this much distance, plus it has to cover the distance equal to the engine to move out completely. Do you agree with this?
Yes, ma'am.
Okay, so speed is distance upon, and it takes 25 seconds for engine to do this. How much time will the train take to completely cross a tunnel, which is 1/4 times as long as the previous tunnel? So in that case, time taken by train is again distance upon speed, where your distance is what? 4 times the length of the tunnel plus the length of the train, right? And speed is the speed of the train or speed of the engine, because in both the cases they are same. Also, I know one thing, that engine length, engine of a train was exactly midway of a tunnel, which is thrice as long as the train. So the tunnel in this case is thrice as long as the train, which means I think there could be an easier way to do this. There could be much easier way to do this. Let's say if I assume my train to be 100 meters in length, can I say my tunnel 1 is 300 meters?
Yes, ma'am.
And I can say my tunnel 2 is 400 meters. Just cancel all these things. Okay, because I'm already told that the comparison between tunnel and train, I can easily use this. Now, when engine is exactly midway, I can say that time taken was 25 seconds. So time taken is nothing but the distance covered by the train. So distance covered by the train is half of the tunnel, which is 150, plus the train, which is 100, upon speed of the train. Did you understand this equation? Clearly, it is not engine alone. No, engine has to be followed by a train. So to completely emerge from the tunnel, the distance that train will have to cover is half of the tunnel plus the distance equal to its own length. So 150 plus 100 is 250. So I can say speed of train is 10 meters per second. Now, what is the second case? How much time will it take for the train to cross a tunnel which is 4 times its length? So in that case, distance that will have to be traveled is length of tunnel plus length of train. And the speed in this case is 10 meters. Where are we going wrong here? Engine of a train was exactly midway of a tunnel which is thrice as long as the train. It completely emerged from the tunnel after 25 seconds. So 25 seconds is halfway tunnel, which is 150 plus 100. And that took 25 seconds. So 250 upon 25 is 10 meter per second. Now, how much time will the train take to completely cross a tunnel which is 4 times as long as the previous tunnel? Oh God. So what is the length of the second tunnel? Is it 400?
4 into 300. It's 4 times the length of tunnel.
My mistake. But even you guys didn't realize. This will be 1200 plus the length of the train, and that is going to take 130 seconds. Sorry. Did we understand this, or you want me to go through it again?
Ma'am, if you could go through it once again.
Wait. See, what's happening over here? Yesterday we did a concept of trains, right? Where if you are covering something with a considerable width, in the distance, you consider the length of the train and the length of the object. You remember that case?
Yes.
So same case over here. There's a tunnel and train is right in between. So if the train has to completely cross the tunnel, the distance that the train will have to cover will be half of tunnel plus the length of the train. That is the logic that I'm using. Now I know that tunnel, the first tunnel is 3 times the length in train. So if train is 100 meters, the first tunnel has to be 300 meters. And second tunnel is 4 times long than the first tunnel. So second tunnel is 1200 meters. Okay. Now the first case, from this half part of first tunnel, train takes 25 seconds to move out. Now I know time is equal to distance upon speed, which is 25 seconds is equal to, what will be the distance covered by the train? Half of tunnel plus the length of train. With the speed of train, because tunnel does not have a speed, if I calculate this, you get the speed of train as 10 meters per second. Understood this? Now in the second case, how much time will the train take to completely cross a tunnel which is 4 times as long as the previous tunnel? So if train has to completely cross a tunnel which is 4 times as long as the previous tunnel, again the distance that train has to cover is the length of the tunnel plus the length of the train itself. So time taken is distance, which is length of the tunnel, plus the length of the train upon speed. Again, speed for the train is going to be same, which is 10. And this will give you 130 seconds. Did we understand this?
Got it, ma'am.
Clear? Sure? All
Yes,
right.
ma'am.
Moving ahead. A train approaches a tunnel MN. So there is a tunnel MN. Inside a tunnel is a dog located at a point which is 3/7 of the distance MN measured from entrance M. So if I break this tunnel into 7 parts, 6. So dog is standing at 3/7 of the distance. So here is dog. I hope everybody is getting the diagram.
Yes.
Now, when the train whistles, now I'm said that train is approaching the, so train is coming from this side. I don't know how far the train is, but it is approaching the tunnel. Okay. Now, when the train whistles, the dog runs. If the dog moves to the entrance of the tunnel, the train catches the dog exactly at the entrance. There are two cases. So if the train is coming here and dog is running towards this side, they meet exactly at this distance, at this point. And second case is if the dog moves towards the exit. So train is still moving, but if the dog moves towards the exit, the train catches the dog exactly at the exit. So this is their meeting point. Do you understand this?
Yes, ma'am.
What is the ratio of the speed of train to that of speed of dog is what I'm supposed to calculate. Let's say this entire tunnel is 7x because I've divided tunnel into equal 7 parts where each part is x. And let us say train is at a distance of d from the tunnel because this distance from where the train is coming is not known to me. So I'm assuming it to be d. Okay. Now let's check the first case. What does the first case say? That train and dog, they move towards each other and they meet at point M. So can I say time taken by both of them to reach point M would be same?
Yes.
Correct. So if time taken is same, which means their speed and distances are equal ratio. So speed of train upon speed of dog is equal to the distance covered by the train. What is the distance covered by the train in the first case? In the first case, what is the distance covered by the train? D. And what is the distance covered by the dog?
3/7.
3x, no? If total distance is 7x, every part is x, so dog covers 3x. Did we understand the equation? This is very important.
Yes, ma'am.
Okay. All right. Now, second case. In the second case, again, train and dog are moving in the same direction, but still they meet at the same time. So in this case also time is constant. So can I say in this case also speed and distance will be in the equal ratio?
Yes.
So speed of train upon speed of dog. So what is the distance covered by the train in the second case?
D plus 7x.
Very good. And distance covered by dog in the second case?
4x.
4x. Clear with both the equations? Now clearly both of these equations gives me the ratio of speed of train and dog. So can I just compare the right hand side for both the equations? Are you getting me? So if I compare this, what am I getting? 3D plus 21x is equal to 4D. So your 21x is equal to D. Clear up till here? Now what is asked to me? What is the ratio of speed of train to speed of dog? Which means I am asked ST by SD, which is D upon 3x. So can I say it is nothing but 1 by 3 into D by x? Now what is D by x according to this solution that I found out?
Twenty-one.
21. So speed of train and speed of dog is in the ratio 7:1. Do we get this?
Yes, ma'am.
All right. Let's look at this. Amit and Dinesh are brothers. One day they start at the same time from their home at Nagpur railway station for Nagpur railway station in their respective cars. Now Amit took 25 minutes to reach the station. After reaching the station, Amit found out that Dinesh is 5,000 meters away from the station, which is 5 kilometers. Now, distance between Nagpur station and their house itself is 30 kilometers. Now, next day, Dinesh decided to start 7 minutes early. If they drive at the same speed as the previous day, then Amit will reach the station how much earlier or later than Dinesh? Okay. What is the distance between home and station? Let's try to get all the information. Distance between home and station is?
30 kilometers.
Now, Amit covers the entire distance in 25 minutes, correct? So, can I calculate the speed of Amit from this information? Speed of Amit would be distance upon time, and because time is in minutes, I will have to convert it into hours. Do we understand this?
Oh, yes, ma'am.
Okay, so it is 1800 upon 25. What are you getting as your time? Sorry, as your speed? Clear with this?
70
Yeah,
kilometers.
correct. Now let's look at Dinesh's situation. What happens is Dinesh is still 5 kilometers away from the station, which means when Amit has reached the station, Dinesh has covered only 25 kilometers in 25 minutes. Do you agree with that? So speed of Dinesh would be distance covered by Dinesh upon time taken by Dinesh, which would give you 60 kilometers per hour. This part is very important.
Ma'am, could you explain the Dinesh part once?
When Amit reached the station, what did he see? That Dinesh is 5,000 meters away from the station, which means 5 kilometers away from the station. So Dinesh has only covered 25 kilometers in the same 25 minutes that Amit reached the station in.
Okay, so it's 25 by 25. Okay, got it.
So we got the original speed of Amit and Dinesh. Now, if we go back to the next part of the question, next day Dinesh decided to start 7 minutes early. So again, next day also Amit is not changing anything in his time and all, and his speed and time is same as the previous day. So Amit will still take 25 minutes to cover 30 kilometers at his speed of 72 kilometers per hour. Agreed?
Yes.
Now what is Dinesh doing is, he's starting 7 minutes early. So basically, if I have to draw, if Dinesh starts 7 minutes early, which means that before Amit starts, Dinesh would have already driven for 7 minutes, but that would not help. Okay, let us try one thing. At this speed of Dinesh, let us see that how much time would Dinesh have taken originally to reach the station on time. I mean to reach the station. Dinesh's speed was 60 kilometers per hour and the station was 30 kilometers, which means Dinesh would have taken originally half an hour to reach,
Yes.
which is 30 minutes. So originally Amit takes 25 minutes and Dinesh takes 30 minutes to reach the station. The difference is 5 minutes. If Dinesh starts 7 minutes early, which means Dinesh will be reaching 2 minutes earlier than Amit. Do you understand this?
Yes.
So if Dinesh reaches 2 minutes earlier than Amit, what would be your answer? Amit will reach 2 minutes later than Dinesh, and 2 minutes
Yes.
is nothing but 120 seconds.
Got it.
Okay, moving forward. A car traveling after traveling 28 kilometers from a point A, developed some problem in the engine and the speed became 4/5 of its original speed. This is point B. So what happened? The first case was, after traveling 28 kilometers from A, the car developed some problem. So here the speed was S and now the speed became 4/5 of S. Do we understand this? Okay. As a
Yes.
result, the car reached point B 45 minutes late. Okay, clearly because with speed S, the time would be T, but with speed 4/5 of S, when the speed reduced, the time would have also increased. Do you understand this?
Yes.
Originally the speed was S and now the time has become 4/4 of S. So basically, in this second part of the journey, see, first part of the journey, there was no problem. But in the second part of the journey, because my time has increased, I'm reaching 45 minutes late. So the difference between these two timings has to be 45 minutes.
Yes, ma'am.
Okay, fine. Now let us see what is happening ahead. If the engine had developed the same problem after traveling 40 kilometers from A, so the second situation is, instead of 28 kilometers, if the engine would have covered more 12 kilometers and developed the problem after 40 kilometers, they would have reached B only 36 minutes late. So in that case, this speed and this speed would still be S, but this speed would be 4/5 of S. Correct? So this time would not have mattered, but this time would have been 5/4 of T. And this was 36 minutes late. What is the distance between A and B in terms of kilometers? Is what is asked. So what I'm going to do is, I'm going to divide the entire journey into 3 parts. And in the first part, even this part of the journey had 4/5 of S speed and thus 5/4 of T time, correct? So now let us compare both the journeys. In both the journeys first part, is there any difference in speed and time? In the first part, if you see your speed and time in both the cases is same. So will that bring any difference in both the journeys?
No.
No, and this is 12 kilometers. Okay, so first part is not contributing to any difference. If you go to the third part, in the third part, first case had this speed and time, second case had this speed and time. Is there any difference between speed and time in both the cases? I know the speed has reduced, but still both the cases, it is same. Do you understand what I'm trying to say? The total distance, what I want to compare is, in both the cases, if you see, the difference between time taken is 9 minutes. So I want to figure out where is this 9 minutes coming from. Are you getting it? I'm not comparing with the original ideal situation. I'm comparing both the problematic situations. But both problematic situations are also different. So I want to compare the difference between them. Are you getting my point now?
Yes, ma'am.
So I'm dividing my entire journey in 3 parts. First 28 kilometers, nothing has changed in both the cases. And the last distance, I don't know how much, after 40 kilometers, where both the cases, the speed has reduced, the time has increased by the same fraction. So again, this part of the journey is not contributing to these 9 minutes. Do you understand my point now?
Yes, ma'am.
Okay, so now my problem lies here. This 12 kilometers, if you see here, the time taken was 5/4 of t, and here the time taken was t. So this difference in time has to be 9 minutes. Because only this part is contributing to the difference. Which means 1/4 of time is 9 minutes. So t is 36 minutes. So what is t? This t is 36 minutes, or this t is 36 minutes. Basically, now I can use this data in the first part. I know that in the first part, speed into time, which is 36 minutes. If I have to compare, if I have to convert it into hours, it is 60, gives you distance, which is 28 kilometers. I'm using this t for the first part.
Yes, ma'am. Got it.
So now if I have to calculate this, what is S coming down to? S is coming down to 140 by 3 kilometers per hour. You can leave it as it is. 1 minute. We might have made a little mistake over here. Okay. Coming back to this, I know that my time here is coming down to 36 minutes, right? It is for the second part, where I know that S into T again is giving me not 28 but 12 kilometers. My time that I am getting over here is for the second part, right? Which means your speed into your 36 upon 60 is giving you your distance, which is 12 kilometers. So this will give your speed of train is nothing, a car is nothing but 20 kilometers per hour. Now I can use this data to find the distance between points A and B. How would I do that? So the first 2 parts I already know the distance. For the last part, if let's say if I know my speed is 20, which means 4/5 of my speed is going to be 16, right? And if I know that, let's say my time taken, but in this case, again, it's going to land at 4/5 of my speed, and I'm reaching 45 minutes late. I will still have to use my one of the equations. This is going a little lengthy. I'm thinking for an easier way. There has to be an easier way for this. Speed became 4/5 of its original speed. It would have reached B only 36 minutes late. So the difference here is 9 minutes. So what I'll have to do is, in the first case, when the speed was S, the time taken to cover the second part, I think we should solve this again. It will come, but for the second part entirely, if I have to see, okay, let's take the second case over here. So here, if you see this second case, in the last part, my speed and time has changed. So in the last part, instead of my speed being 20, now my speed is 16 because it has become 4/5 of t, and which leads to train being 36 minutes late than usual. So if the train would have taken t minutes over here, or let's say t1 minutes over here, the train takes t1 plus 36 minutes over here. Because individually, if I have to take the cases, the last part in the second case is making a difference, right? So with 20 and a time taken t1, 16 and a time taken of t1 plus 36, this is similar to what we did before, where only one case was existing, which means 20 into t1, this distance has to be equal to 16 into t1 plus 36 in the second case, because distance in both the cases is going to be same. Fine. If I now have to compare 20 t1 is equal to 16 t1 plus, do not necessarily multiply this and keep, just write it 36 into 16. So I know 4 t1 is 36 into 16. So t1 would be 36 into 16 divided by 4. Which will be 36 into 4, which will be 144 minutes. So the last distance is nothing but 20 into 144 minutes. Either of the cases I can take. So 20 into 144, and because this is in minutes, I'll have to convert it into hours. So 144 by 3 is going to give me 48 kilometers. So basically 28 plus 12 plus 48, my answer is total 88 kilometers. I know this has gone little confusing. So if you want, we can take up certain part again, or we can just try to rewrite the entire thing. The answer should be 88 kilometers. Or we can do, at least, you want me to restart it and do it in a little quicker, but a better way?
Yes, ma'am.
There were
Just
certain,
remember the steps.
because there were certain points where we kind of got lost. Okay. You want to write anything from this, or should I start again directly?
Yes, ma'am. You can start fresh.
Okay. Let's look at this question again. So let's say there is a point A, there is a point B. Now what is happening is, a car traveling, after traveling 28 kilometers from point A, it developed some trouble. Okay. So which is why originally, after 28 kilometers, originally the speed would have been S and the time taken would have been T. But because there is a trouble, now the speed is 4/5 of S, and time taken because of that is 5/4 of T. And this difference is 45 minutes. So if I clearly solve in this case only, can I say 5/4 T minus T is 45 minutes? Do you agree with this? So 1/4 T is 45 minutes. So T is nothing but 180 minutes. So this part, originally if I had to cover, the second part originally if I had to cover in this case, would have taken 180 minutes. Is everybody with me in the first case?
Yes, ma'am.
So 45 minutes is the difference between the original
Yes,
time and 5/4 time.
correct. Because the car is reaching 45 minutes late. So originally it would have reached at T time, but now it is reaching 45 minutes more. So this, if you see T and 5/4 of T, the time taken has increased because of the problem.
Got it.
Clear up till here? Okay. Now what I'll do is I'll take another case with another pen. Engine developed the same problem, let's say after 40 kilometers. So instead of 28 kilometers, engine was fine for 28 and remaining 12. So till here there was no problem. But after that, instead of speed being S and time being T1, because speed is same in both the cases, but because the distance has reduced, the time will change. Instead of speed being S and time being T1, now the speed has become 4/5 of S and time has become 5/4 of T1. Do we understand this?
Yes.
Okay. And because of this, what happens? The train reaches only 36 minutes late, which means in this case, 5/4 of T1 minus T1 is 36 minutes. So 1/4 of T1 is 36 minutes. So what is your T1 going to be? 36,
144.
which is 144 minutes. Okay. What is the distance between points A and B in kilometers? Now, if I have to compare all the cases over here, see if I again divide this journey into 3 parts. If you see the last part, I know the distance between in the first and the second part. If I compare the last part, here if you see, S is same in both the cases, right? But this T is for this entire stretch. And this T is only for the last stretch because that is where the time had changed. Do you understand this? In the
Yes.
first part, my time taken was for the entire second and the third part of the stretch. In the second case, my T1 is only for the third stretch, which means the difference between them, which is nothing but 36 minutes, is the difference that will be here. But again, that will not help. I think we are missing out on something which is a very easy trick. Give me a day. I mean, I think right now my mind is blocked with this. Okay, let's leave this question here. I promise to get back with a much better method on Thursday. Let me just go through it again. This is doable, but this is going to take a lot of time. Answer we got, but this is very lengthy and I don't feel we should go with this lengthy method. We will get the answer 88 kilometers. That is not a problem, but this is not the right way to do is what I feel. Let me try to figure out a better method. If we don't get a better method, we'll go with this method. Fair?
Okay, ma'am.
Yes, ma'am. Sure.
Sorry for this, but I don't want you to take through this method unnecessarily. Let's move ahead.
Yes, ma'am.
Let's look at this. Rohit walks to and fro from a shopping mall. He spends 30 minutes in shopping. If he walks at a speed of 20 kilometers an hour, he returns to home at 19 hours, which means at 7 o'clock. And if he walks at 25 kilometers an hour, he returns to home at 6:30. How fast must he walk to return home at 6:15? So basically, Rohit is going to the shopping mall, shopping for 30 minutes, and he is coming back. Right? So if he's walking at a speed of 20 kilometers an hour, now he returns at 7 o'clock. So basically 20 kilometers an hour. I don't know the distance between Rohit's house and shopping mall. So let's say distance covered is 2D at a speed of 20 kilometers per hour. So time taken. So time taken is nothing but 2D upon speed. And if he walks at 25 kilometers per hour, he returns home at 6:30. How fast must he walk to return at 6:15? Okay. So in this case also, can I just compare in all the cases, in all the three cases, my distance is same. So if I just compare my time, let's say in the first case, if my time is t and my speed is 20 kilometers per hour, in the second case, my time is reducing by half an hour and my speed is 25 kilometers per hour, and still my distance is going to be same. And in the third case, my time has to reduce by 45 minutes, right? So if I have to write in terms of hours, my time has to reduce by 45 minutes. And I'm asked what will be this speed. Correct? Does everybody agree with this?
Yes, ma'am.
In all the three cases, the distance is same. So what I can first do is, I can first compare these two and find the value of t. Can you do that?
Uh, 10 by 25?
T? 5 by 25 by 10, no?
Sorry, 25 by 10.
5 by 2, and everything is in terms of hours because I think I've already converted this into hours, right? So 5 by 2 hours. Now if I substitute that over here, and if I compare this, let's say the first and the third case, can I do that? 5 by 2 into 20 is equal to 5 by 2 minus 3 by 4 into S. Can you find the value of S?
$200 by 7?
Which would give you, I think none of these should be the answer in this case. It's
Yes,
coming around
ma'am.
28, no?
Yeah.
Okay. And as such, I mean, it just clicked me. I would actually not have solved. If I want to reach faster, I'll have to increase my speed. Wouldn't I have to? From 6:30, I want to reach at 6:15. I would have to increase my speed. So my answer has to definitely be more than 25.
Yes.
I would not have solved. I would just have, if that would have clicked faster, I would have clearly straight away marked my answer as none of these, because none of these are greater than 25. Logical?
Yes, ma'am.
Okay. All right. So I think we are going to end our today's class here.
Thank you, ma'am.
Thank you so much.
Thank you, ma'am.
Thank you.